Now I want to talk about sector area. Well, just like it sounds, it's a part of an area. So it's like having a slice of pizza or a slice of pie. So it's part of the whole again. So I have my theta again, and when my whole area, right, so my sector area, which we just denote by A, is part of the whole area, and the area of a circle is pi times radius squared. And I have my theta again in radians, so I know that my area I'm looking for over the total area, my part over my whole, is equal to my angle over my whole, which is 2 pi. And I can solve for A. A is theta over 2 pi. Remember, part and whole. And as long as you keep part on top and whole on the bottom, it'll work. And then multiply by pi r squared. And so that means that A equals 1/2 theta times r squared. And theta, again, must be in radians. But it's just the same idea as the arc length. It's just a part and a whole. So let's look here. I have a radius of 6 feet and a theta of 2 radians, and I want to find my area. Well, my area equals 1/2 my theta, which is 2, times my radius, which is 6 squared, which is 36 feet squared. So that's the area of that little piece. I have another example. I have a radius of 6 and my area is 8. So I know that my area is 1/2 theta r squared. I'm looking for theta. So A, which is 8, equals 1/2 theta times 6 squared. So I have 8 equals 18 theta, which gives me 4/9 radians. Now let's look at a word problem. I have an engineer who wants to design a water sprinkler that will cover a field of 100 square yards that is in the shape of a sector of a circle of radius 15 yards. So that's what I need to know. I know my whole area is 100, and I want to know the angle. So I can make a picture. I have some kind of field. It looks like this. This is 15 yards. The whole area in there is 100 yards squared, and I don't know what theta is. I'm looking for that. Well, I have 100 is 1/2 times theta times my r squared, which gives me my solve for theta. You can do it on the calculator. You get 0.89 radians. And if you wanted to, you could convert that into degrees by multiplying 0.89 radians times 180 over pi. And then you would get the number of degrees, so it might make a little bit more sense to you.